Okay, I think we've given enough time for others to join. We're going to go ahead and get started today. We have a packed agenda with lots of speakers going on. First of all, we're going to have Joe Qualera. He's going to be giving you kind of an insight of PTC and the Focus Solutions Group, followed by Sean Fanning. He's the Director of Software Development, and he's got a team of people that are going to be talking about the various products today. And then myself, Melissa Wagner, I'm the Product Marketing Manager, and I'll be going over the marketing events, you know, the websites, things like that. And then finally, we're going to have the Q&A session at the end. So Joe, do you want to go ahead and kick things off?
Great. Melissa, can you just confirm that you can hear me okay?
Yep, I can hear you.
Great, great, thanks. Thanks everybody for joining us today. You know, it's great to see that so much business is still getting done in such extraordinary times. You know, I guess I'm sorry to say that we're still here talking about coronaviruses and COVID updates, but you know, here at PTC, we're all working through the same thing I'm sure you're all working through in your work and home lives. And I just want to acknowledge that we continue to really focus on our customers and employees' safety and good health here throughout this crisis that we're all going through. And yeah, we're hopeful that you all and everybody here at PTC continue to be safe while we navigate these uncertain times here. I guess the good news is that it's presented itself some good opportunities for PTC and hopefully some good opportunities for you as well. As a result, we just had our earnings release for our Q3, fiscal Q3 just ended for us at the end of June, and we announced earnings a couple weeks ago. They were really strong. Despite the difficulties with the economy and COVID, you know, the business for PTC was really strong throughout Q3. We announced a 10% growth in our annual recurring revenue, the ARR that you can see at 1.2 billion that we reported, and to have such good growth is really impressive in this time. And you know, again, in our expectations that we set for our next quarter, the quarter we're in now, Q4, is that we'll continue to grow. In fact, we set expectations that we'll grow between 10 and 12% in ARR, or annual recurring revenue, in this quarter. So as you can see here, Q3 earnings and revenue were really good, and I bring that up really just so you can have some confidence that PTC is doing well. We continue to be in really strong financial shape despite very difficult economic times. So, you know, we've said that we'll be around for you for the long haul. We have been, and we'll continue to be. You count on Ada being around here at PTC for a very long time in the future. When we talk about PTC in general, you know, PTC is a global company. You can see here, can you go to the next slide, Sean? If you can see here that, you know, we have many different types of technologies. It's hard to understand how, you know, the Ada products fit into the PTC economy, but just so you know, this company started as a technology company way back when MCAD began. So, you know, you may have heard of Creo or Pro Engineer. It was in those days, and it was kind of the IBM of the PC world back in those days. And then it expanded into product lifecycle management, where our Windchill products were born, where our current CEO came from. And then it expanded again into ALM and service lifecycle management. And then, of course, most recently, the Internet of Things and augmented reality kind of took over after that. And, you know, and then the future expansion of the business created you know, a situation where we have a very large customer base in something that was on that last slide called FSG. And if you look in the overall business inside of PTC, the Ada products fit in the focus solutions group here at PTC, and that's what was in that left-hand pie here that was on that last slide. You know, as far as our verticals go, you can see here that we have several major verticals that are our sweet spot at PTC, and you can see that federal, aerospace, automotive, defense, and industrial are the core components of PTC. We know that many of our Ada customers are in that category, not exclusively, but we have a large portion there. That's a big part of our business here at PTC. Can you go on, Sean, please?
So we wanted to highlight a couple of recent customer successes with our Ada products. One example is with a major defense contractor who purchased ApexAda version 5.0 Linux Cross VxWorks PowerPC in May of this year. This was for a modernization project, basically reusing a substantial legacy source code base that was previously built with a much older version of the Apex compiler technology hosted on Spark. The objective of the modernization was to move to Linux and enjoy economies based on the fact that it's on a less expensive infrastructure. And also they were looking to make innovations upon the legacy source code base. So ApexAda was adopted after a successful evaluation earlier, where a proof of concept was done. A substantial ramp of the project occurred during this evaluation. And key to the success of that evaluation was the support received from PTC's technical support for ApexAda. When a project has been on the shelf for a long time and it's time to make it work with a new version of the compiler, there's usually challenges, and there were a few, but with the help from support, it's a very successful ramp up of their revitalized project. An interesting sign of the times is that progress was enabled by PTC on this effort through providing what we call COVID-19 work-at-home license keys to work around, temporary facility access restrictions that forced engineers to work from home, and security requirements on this project that, for an air-gapped development environment, in other words, no connectivity to the internet. A similar example from earlier this year was the adoption of ObjectAda for Windows 10.x from a US military branch for a new project incorporating a team of 10 developers with a Windows 10 Ada requirement. And they selected ObjectAda for Windows based on prior reputation of the product as being the premier choice for doing Ada development on the Windows native platform. So they upgraded to ObjectAda 10.2, which is the release that we're going to highlight later in this virtual event, after it was released in July of 2020. And again, the project was affected by COVID-19 related site access restrictions and air-gapped development environment requirements. And again, PTC has facilitated progress on this project in the same fashion.
Yeah, thanks, Sean. We wanted to just share with you a couple of the recent things that just happened over the last couple of months. Despite the COVID environment, in turning, I like to tell the stories in terms of turning lemon into lemonade. We have a lot of lemons going on here in the middle of this pandemic. And so when you can find some success, we really want to talk about those to give people some encouragement. Look, the Ada products that Sean just described here for ObjectAda and ApexAda fall under what I referred to earlier as the Focus Solutions Group. This is a division inside the company where we've gathered some products that are really important, like these, mission-critical technologies and tools and software products, and put them together in a business unit or a division of business units to make sure that they get constant focus and don't get lost or distracted from all this new cool technologies that are out there. When you keep hearing about Internet of Things and augmented reality and all this really good, important stuff, but we don't want to let it detract from the importance of our core products that are mission critical. And as a result, we pulled them out of the core parts of the business and created this focused solutions group so that we can make sure that we're giving dedicated resources to support your products and developer tools. And basically, who are we in the focused solutions group? It's certainly an important part of PTC's business. It's recognized that way. My boss, meets regularly. In fact, yesterday he just had a meeting with the CEO. It happens on a regular basis. We're taking care of really, really important deployments and businesses and projects. And the products are being developed. They're being fully supported. We have our own services team. It's a very reliable, resilient team of people that have been put together, to make sure that what you are using for technology works every day and will continue to work into the future. And at the same time, we're leveraging the technologies that PTC has in these disruptive technologies. So when I refer to the Internet of Things or augmented reality, we have the opportunity to leverage those technologies if they can help you. So, we're hopeful that today's session is just one of many where we're having a dialogue with you. We're engaging with you in a two-way communication, even though today we're talking to you. We hope that you'll talk to us and give us your feedback, and we hear from you directly about what you really need to be successful so that we can leverage all the resources that are available to us to make sure that what you need is what you get. Sean?
Thank you, Joe, for that overview. I'd like to give an overview about our Ada products team. So I'm Sean Fanning. I'm the Director of Software Development, responsible for all of the Ada compiler technologies at PTC, including ApexAda and ObjectAda. We have, as Joe indicated, dedicated resources covering product development, quality assurance, technical support, and consulting services. This is a highly integrated team with many individuals with 25 years plus Ada domain experience and tenure within the team and familiarity with the product lines. We have subject matter experts in Ada and compiler technologies, and this is spread across expertise in both native compilers as well as embedded compiler products. The mission of our group within Focus Solutions Group, which we've referred to as PTC Developer Tools, is to provide world-class, smart, efficient development environments. And what we want to do is speed the construction of intensive native as well as embedded and real-time mission-critical applications. There are a number of market trends that have shaped our vision for the Ada products, their evolution, and our future R&D roadmaps. One of those trends has been just what we refer to as program modernization requirements, the never-ending need to do upgrades to development platforms, even platforms that are supporting legacy target architectures. Also, the shift from 32-bit to 64-bit addressing has been a key trend in recent years. And indicative of those kinds of modernization requirements you see on the screen here, the need to upgrade, for instance, to the latest Oracle Solaris 11 releases for primarily for security and long-term sustainability concerns, the need ever present need to keep current with respect to the evolution of the Linux platform, which increasingly is the platform of choice for Ada developers. Also, another major market trend is just innovations that are occurring with respect to target processors. And in this case, what we have is an industry transition that's occurring from PowerPC to ARM. And so providing support for ARM processors within our Ada technologies has been a subject that we're going to talk about today. And another trend has been the evolution of the Ada language and increasing customer demands for the newer editions of the language, that being Ada 2005 and Ada 2012. So from a high-level perspective, the two main product families that we have for Ada compilers at PTC are PTC ApexAda and PTC ObjectAda. And then within each family, there's a breakdown between the native and the embedded. So in the case of ApexAda, the native compilers are referred to as PTC ApexAda Developer, and the embedded cross-compiler products are referred to as the embedded developer products. Similarly, within the ObjectAda product family, you see specific products that are native compilers, that being ObjectAda for Windows, ObjectAda for Linux, and then the embedded products are referred to as ObjectAda Real-Time. And then there's a more specialized variant of the ObjectAda Real-Time products called ObjectAda Raven, which is providing Ada runtime for the Ravenscar profile subset of Ada 95. All of these products have been used for a multitude of different military and aerospace applications over the years. And today's virtual event is to focus on some specific new product releases that have come about. I wanted to spend just a few moments just highlighting what has happened with respect to the evolution of our Ada products in recent years. With respect to ApexAda, we've had a number of significant new and enhanced product releases, starting with ApexAda version 5, where we introduced Ada 2005 support. Following that was ApexAda 5.2, providing Linux native 64-bit. And then beyond that were several embedded products for 64-bit targets. The first was VxWorks 7 for Intel processors. Next was for the Apex exec RTOS, which is for bare metal deployment on, in this case, Intel hardware. Along the way, we've added support for Solaris 11.4, SUSE Enterprise Linux version 12, Service Pack 3 and later, as well as Red Hat Enterprise Linux version 8 and corresponding CentOS equivalent distributions. So you can see just a continual evolution of the Apex product towards new technologies, new releases of operating systems. And our latest release is the ApexAda version 5.2 Linux cross Linux ARM v8. This is our initial product offering for 64-bit ARM processors. Another new release happened just this month was the release of the ApexAda standalone FlexLM server kit. This is allowing customers to upgrade the license manager component of all ApexAda products to the latest FlexLM version 11.17 to address both functionality issues on newer operating systems as well as security concerns. And then along the way, there have been quarterly updates for ApexAda to address reported problems in basically 4 different major versions of Apex that are still supported. With ObjectAda, our evolution started with ObjectAda 9.1 to introduce Ada 2005. This was followed by 9.2 that added 64-bit code generation within ObjectAda. Then there was the major 10.0 release that was providing an initial subset of the Ada 2012 language features, as well as a new architecture and design for ObjectAda for Windows to support Visual Studio 2017 and the Windows 10 SDK, basically modernizing the whole ObjectAda for Windows product to make it follow that market trend of increasing importance for the modern Microsoft tools as well as Windows 10. We've had this incremental strategy of completing Ada 2012 support, and that was completed in July of this year with the release of ObjectAda version 10.2, providing the complete Ada 2012 support as well as a significant upgrade to our Eclipse plugins for ObjectAda. And this is the release that we're going to highlight in more detail in a later segment of today's event. We've also had many updates for ObjectAda as required to address customer reported issues. So our next segment of today's virtual event is to focus on ObjectAda for Windows version 10.2. Presenting this segment will be Lynn Henderson, who is a principal technical support engineer and has been supporting ObjectAda for a number of years. And I'd like to introduce Lynn at this point to tell you about this new exciting release.
Okay, this is Melissa again. I just want to jump in. But Lynn, before you get started, more attendees have joined. Just wanted to remind them that they can enter their questions in the question box at any time so we can get to those questions. So just wanted to interject. Go ahead, Lynn, thanks.
Okay. The latest version of ObjectAda and ObjectAda64 for Windows was released just this last July, as I think Sean mentioned. These products allow users to develop, build, and debug either 32-bit or 64-bit native Windows applications. The 10.2 release has support for all Ada 2012 language features, as well as backward compatibility to allow compilation of Ada 2005 and Ada 95 source code. ObjectAda runs on Windows 10, although it also works with older versions of Windows as far back as Windows 7. ObjectAda is compatible with Microsoft Visual Studio 2017 and the Windows 10 SDK. It's also possible to reconfigure ObjectAda to use Visual Studio 2019 and a different version of the Windows 10 SDK than the one included on the ObjectAda installation media if the user chooses to do so. Users can choose to work in an Eclipse development environment with ObjectAda via the ADT Eclipse plugins included with the products. These plugins are compatible with the latest versions of Eclipse, including Eclipse 2020-06. The ObjectAda products include a compiler, builder, runtime library, and debugger, all supporting development of source code written in either Ada 95, Ada 2005, or Ada 2012. The ObjectAda for Windows compilers generate two different formats of debugging information. One can be consumed by the ObjectAda debugger, and the other is code view debugging information that can be consumed by the Visual Studio debugger, giving the user a choice of debugging environments. There are two sets of Windows bindings included with the ObjectAda products. The Win32 Ada bindings provide Ada bindings to core Windows APIs. And the Win API bindings, which are generated from Windows 10 SDK header files, allow the user to call functions in the Windows SDK. ObjectAda includes a GUI builder, which is a tool that lets the users quickly and easily develop and build Windows GUI programs in Ada. Additionally, there is support for the Ada Semantic Interface specification, also known as ASIS, which allows development of tools that can extract Ada semantic information from Ada libraries. And last but not least of the ObjectAda features is the Ada nav toolset, which includes tools that generate HTML call trees and data dictionaries, allowing users to easily conceptualize and understand complex Ada programs, as well as providing a profiling tool. Just to expand a little on a few of the new language features supported when compiling with ObjectAda 10.2 in Ada 2012 mode, we have, among others, aspect specifications, dynamic contracts, which include preconditions and postconditions for subprograms. You can see a small example of these at the bottom right of this slide, I think. And also assertions for types that are checked dynamically. There are new flexible forms of existing expressions, support for loops and quantified expressions using the iteration specification form, and also functions that can have out and in-out parameters, which were previously only allowed for procedures. New features in ObjectAda 10.2 also include program library extensions such as Ada.strings extensions, Ada.wide characters handling, Ada.wide characters handling, Ada.directories extensions, and new containers packages. Back to you, Sean.
All right, thank you, Lynn. Our next segment is a couple of demonstrations of ObjectAda for Windows. Hello, welcome to a demonstration of PTC ObjectAda for Windows. We start ObjectAda from the Start menu, selecting the PTC ObjectAda program group,
In this example, we're showing that multiple editions of ObjectAda can be installed on the same system concurrently. If we select ObjectAda64 version 10.2 and we want to say we want to check the configuration with respect to the versions of the Microsoft Visual Studio build tools and the Windows 10 SDK that are going to be used by ObjectAda, the utility currently shows that we're using the default versions, the 2017 build tools, and the version of the Windows 10 SDK that comes with ObjectAda. We can alter this configuration, for instance, by selecting the Visual Studio 2019 tools, by navigating to the appropriate directory, selecting that folder, and then the new choice becomes available in the utility. Similarly, I've got multiple versions of the Windows 10 SDK installed, so we can select the most recent version and go with that. We save the configuration, and then if we start ObjectAda at this point, that will be the configuration of the Microsoft SDK that we're going to use. So here we started ObjectAda. We'll create a new project, selecting C projects Ada 2012, and we'll create a folder for our project called GDI demo. And we will select that folder for our project. We'll give the project the name GDI demo. We could indicate whether we want Ada 95, Ada 2005, or Ada 2012, but we'll go with Ada 2012 in this example. We'll hit Create, and that brings up a file selection box asking us to select the files that we want to add to the project. In this case, we're going to add all of these files from the Win32 Ada GDI demo example that's provided with ObjectAda for Windows. We've added the files to the project at this point, and if we open up the first file, bounce.adb, we see that it references the Win32 Ada binding. So we need to alter the project settings accordingly and configure it first off to say that this is going to be a Windows graphical user interface application. And then secondarily, we need to add a search link so that it will locate the Win32 Ada binding as a program library that these compilations will need to reference. So that's in our ObjectAda installation directory under Win32 Ada binding lib. Select that folder, save those project settings. At this point, we're ready to compile, so we can select build, compile all to compile all the files in the project. And when the compiler is finished, we can then select build, and select the main unit we want to be the main program, hit OK, and the ObjectAda builder builds the executable. If we execute the program by using the exclamation point icon, you can see that this example program just simply draws random shapes on several different windows and has bouncing balls that it's managing in one of the windows. So that's what this example does. Say we're suspecting a problem with the bouncing balls and we want to debug procedure ball bounce. If we navigate to the source for ball bounce, we can set a breakpoint at the beginning of this, insert remove breakpoint, and then start the debugger. So if you do build, start debug, go, that starts the ObjectAda debugger, and we're now halted at the initial place where procedure ball bounce was called. Shown here are the locals window and the call stack window. We can go down the call stack to look at the places where the subroutines were called, leading up to the place where we're halted currently in execution. We can hit F5 and go to the next occurrence of the same breakpoint. The locals window is showing us our local variables. So that's the essence of debugging using ObjectAda's IDE. We stop the debugger with debug stop debugger, and then we're back to just looking at the project with the standard workspace view. It's also possible to use the Visual Studio debugger to debug Ada programs. In that case, we would navigate to our Visual Studio 2019 directory in the program in the Start menu. Select the command prompt for native x64 tools because we're working with 64-bit native in this example. Let me increase the size of the font here so that we can see what's going on. And there we go. So if we change directory to C:\projects Ada 2012, we see our directory with GDI demo in it, CD to GDI demo, and CD to the debug target of the project. And there we see the executable for the example that we just ran. And at this point, we can say dev env, that's the Visual Studio IDE, and we give the name of our executable, GDI demo.exe. That starts the Visual Studio IDE with basically making a project for us on the fly. We can do debug step into to basically launch an instance of our executable under the control of the Microsoft Visual Studio debugger. And in this case, we've done a step into the program just so we can get an initial start. Then if we open up, for instance, our bounce procedure, our bounce.adb body for the package bounce, and we look for procedure ball bounce again. Ball create, ball destroy, ball bounce, there it is. So we can set a breakpoint, just like we did in ObjectAda, set a breakpoint, insert breakpoint, type F5 to continue execution, and now we're halted at this location in our Ada source code with the Visual Studio IDE, looking at our local variables, just like we were in the ObjectAda IDE, and we can do F10 to advance through the source code and basically do basic debugging. The fidelity of looking at Ada in the Visual Studio IDE is not as good as it is in the ObjectAda IDE, simply because Visual Studio is not that aware of Ada data types and how to display them correctly. But anyway, that gives you a brief overview of how to use ObjectAda for Windows using both the ObjectAda IDE and the Microsoft Visual Studio IDE. Thank you for attending this demonstration. Hello, welcome to a demonstration of the Ada Development Toolkit, ADT, Eclipse IDE for ObjectAda. In this case, we'll be using the ADT with ObjectAda for Windows 10.2. To get started, the first thing we need is to get a Java 8 runtime installed, and PTC recommends using Amazon Corretto, which is a pre-built production quality distribution of the OpenJDK Java 8 implementation. So you simply download this from the Amazon Corretto website and install it, and that component should be ready to go. Second, you'll need to download and install Eclipse. So you go to the eclipse.org website and click on download, and you can download the 64-bit installer for Windows, or you can select downloading a particular package. Popular choices would be the Eclipse IDE for Java developers, which is in fact what we're going to use today. We've already downloaded Eclipse Java version 2020-06. That's the latest release of Eclipse. And if we extract the contents of this zip file that we've downloaded, what that produces is a directory called Eclipse. And to get started with installing the Eclipse plugins for ObjectAda, we run the Eclipse IDE. And upon starting, it will ask us to define where we want our Eclipse workspace to be. So to keep things straight, I always create an Eclipse workspace that's unique to each version of Eclipse that I'm using. So in this case, it'd be users S Fanning Eclipse 2020 06 workspace will be the folder that we'll use for our workspace today. With that, we start the Eclipse IDE, and once we get started, it will bring up a welcome screen, which we can dismiss. And then we want to install the ADT plugins from ObjectAda. So we click on Help, Install New Software, and it wants to know the site from which to add the new software or the new plugins. This can either be a website, which ObjectAda has one that you can install from, or we can just install from our local computer. In this case, we're going to install ObjectAda ADT version 4.0.0, and we'll install it from a local update site, as they're called, from our ObjectAda 64-bit installation, which would be PTC ObjectAda64 version 10.2. ADT is the directory that has the plugins. Select that folder and click on Add. And then it lists what's contained at that update site. We select those components for installation. Click Next. Accept the license agreement. Click Finish. Install it regardless of whether it's got signatures. Restart the Eclipse IDE. At this point, we will enter the Eclipse IDE with the ADT plugins installed. So we'll switch from the default perspective within Eclipse to the Ada perspective. And then we will create a new project, a new Ada managed project. And it's going to create it in our workspace, in our Eclipse workspace, and we're going to call it GDI demo. We click Next. Next, it wants to know what is the tool chain or the ObjectAda tool chain that's going to be used for this project. So we don't have any defined currently, so we've got to add them to the Eclipse configuration. So we add, in this case, we'll add ObjectAda 64 for Windows version 10.2. Select the path to that to the installation of ObjectAda, and click Next. And then it wants to know what directories to utilize for source code display within the Eclipse IDE. We're going to be using the Win32Ada binding, so we'll add that directory of source code, which has all these source Ada's package specs in it. So we'll add that to the list. Finish. So that gets ObjectAda64 for Windows version 10.2 defined as a tool chain. We can also add ObjectAda 32-bit. So that'd be ObjectAda for Windows version 10.2. Selecting program files, PTC, and then in my case, it would be ObjectAda v102. Select that folder. Next. Again, we'll add the Win32Ada just for consistency. The source directory for the Win32Ada binding. Finish. Then we'll select ObjectAda64 and apply that and apply and close. So now ObjectAda64 for Windows is our selected tool chain for this new project that we're building. We click Next. And now we define the properties of the project. So first off, we want to link this as a Windows application. So we'll select application type Windows. We're going to get all of the debugging info, that being either ObjectAda generated debugger information as well as code view debugging information. And for search, we need to add from an external source, that being the file system outside of the Eclipse workspace, we need to add the program library for the Win32Ada binding that's going to be used in this example program. So we'll select our PTC ObjectAda64 version 10.2 Win32Ada binding lib directory, and we'll select that, and that pretty much concludes the project options that we need to set. So we'll click Finish. And at this point, we need to add files to our Ada managed project that we've created. So we'll do File, Import, because we're importing from the file system outside of the Eclipse workspace. Select General, File System, Next. Browse to the directory that we want to import from. So it's ObjectAda64 examples, Win32Ada GDI demo. Select that folder. We'll select all the files and then unselect one that we don't want, which is a project file for the standard ObjectAda IDE. And at this point, that's what we want to import, so we'll click Finish. And now those files have been added to our project. And because we have automatic building turned on in the project, build automatically, what has happened is the compiler has already compiled all of the source files that we just added to the project. We'll turn off automatic building just so we can follow what's happening behind the scenes. So in this case, we've compiled all the files. For instance, we can open up the bounce package and look at this. And if we want to, say, find a particular procedure within bounce, like there's a procedure called ball bounce, which bounces the balls in the demo here that this creates. We can use the browser here in the Ada Navigator to find all of the subprograms in this package. So here's procedure ball bounce. So we've navigated to that. We can say, well, we're suspicious about this, so we're going to add a breakpoint at the very beginning of this. So we've shown how to use the Ada Navigator. We've shown how to set a breakpoint. Now let's look at how we actually create a main, link the main program and run it and debug it. So in this case, we would go back to the source navigator, select the source file for the main program, which in this case is procedure GDI demo. Do right mouse click on the source window and select link main units. Then that brings up a dialog that asks you to select, well, what is the procedure that is to be the main program? In this case, there's only one. We select it called GDI demo. And then the ObjectAda builder goes off and invokes the Microsoft linker to link the executable. To see this program run, we would select Run, Run Configurations, Ada, create a new launch configuration, and we'll call this Execute GDI demo. If we had particular requirements to give this this program command line arguments, we could type them in here and set up the environment in which this program is to be executed. In this case, we don't have any need to set any of that, so we just apply this and run it. And you see the program runs. It creates 3 sub-windows and has the bouncing balls in the left-hand window. So to run this under the control of the debugger, we would, again, do Run, Debug Configurations, Ada, create a new configuration. We'll call this new configuration Debug GDI demo. We'll apply that configuration and we'll debug it, and we'll click Debug. The program starts and it's halted execution at the breakpoint that we set in ball bounce. We can get a better view of this by switching our perspective from the Ada perspective to the debug perspective. in which case we see the stack of all the calls, like ball bounce was called from bounce refresh, which was called from bounce proc, and so on. In this view on the right, we see the local variables. So here are all the local variables for the procedure that we're currently halted in. And that's pretty much an overview of how you get started with setting up the Eclipse plugins, defining the ObjectAda tool chains that the plugins will be using, how you create a project, and how you build the project, execute the program, and run the ObjectAda debugger from this IDE.
So after the demonstrations, our next segment is to focus on our latest ApexAda release, which is our PTC ApexAda embedded version 5.2 Linux cross Linux ARM V8 64-bit. Presenting this segment of today's virtual event is Sam Sherens, who's a principal technical support engineer, our lead on technical support for PTC ApexAda.
Hi, I'm Sam Sherens from ApexAda Technical Support. These next few slides provide a brief overview of our newest product release in the ApexAda family, ApexAda Embedded version 5.2, running on a Linux host and targeting an embedded Linux OS on a 64-bit ARM processor. This is the first ApexAda product to target an ARM processor. This embedded product was tested on an Intel x86-64 host running Red Hat Enterprise Linux version 7.7. The Apex 5.2 product generally supports RHEL or CentOS version 7 and 8 and SUSE Linux Enterprise version 12 up through 12.3. Apex uses the linker and system libraries of an embedded Linux cross-development system to create executables for the ARM target. The system we tested with was Linaro version 7.5.0. The compilers generate code for the Arch64 instruction set that was first introduced on ARM V8-A target processors. Some examples are listed here. The target processor family is still under active development. Apex was tested running an OpenSUSE Leap version 15.1 operating system on the target. Apex is designed to work with any Yocto project compatible Linux distribution, such as the ones you see listed here. Here are some examples of embedded ARM computers that one might target with ApexAda. On the left is a Raspberry Pi, very popular because of its low cost and versatility. We tested ApexAda on a couple different Raspberry Pi models. Pictured on the right is a Curtiss-Wright VPX3-1703. This is a 3U VME bus-based system using a high-speed VPX connector. It's designed for rugged, space-constrained, low-powered conditions. It has a high-performance quad-core A53 processor and has a wide array of I/O capabilities. We didn't test ApexAda on this target specifically, but we're picturing it here as an example of the type of high-end ARM embedded target that an ApexAda customer might use. Curtiss-Wright provides a Yocto-compatible Linux BSP for this board. So why are we adding ARM to our family of embedded targets? Historically, PowerPC has been the most popular embedded processor for aerospace and defense applications. In recent years, Intel processors have come into more use, but the increased performance comes with some trade-offs. Looking toward the future, we expect ARM processors to get more popular in the aerospace and defense world. ARM processors are found in most mobile consumer devices worldwide, driving design trends toward low cost, low power consumption, and improved performance. The 64-bit A53 that ApexAda targets is a proven model with a long lifespan ahead. There are numerous OS choices available for ARM, including the Yocto-compliant Linux that our new product targets. The next slide shows the 64-bit embedded variants of ApexAda 5.2 that are now available. We target Intel x86-64 running a VxWorks 7R test, x86-64 running our ApexAda exec bare board Ada runtime system, and now the new product, a 64-bit ARM v8 running Linux. As with all Apex embedded products, the host side compilers and other standard features are included. This last slide is a brief overview of the ApexAda product family. If you've used Apex in the past, the newer versions of ApexAda will be very familiar in look and feel. ApexAda is an IDE with Ada 95, Ada 2005, and CC+ compilers, language sensitive editors, architectural control features, a built-in CMVC system, excuse me, a powerful debugger, test automation and coverage analysis tools, and more. The product supports the hosts and targets you see listed here. For native compilation, we support Solaris OS on both SPARC and Intel x86, and Linux on both x86 and x86-64. We now support 4 embedded target runtimes: VxWorks on Intel x86 and 32-bit PowerPC, LinkSauce on PowerPC, our own Ada runtime called exec on x86, PowerPC, and MIPS, and the new product, embedded Linux on ARM. And now back to Sean for a preview of future product plans.
Thank you, Sam. So we wanted to highlight some things on our roadmap for future releases. And first up on that roadmap is our ObjectAda for Linux version 10.2 releases. These will be 2 products similar in spirit to the 2 products that we have for the Windows native platform. This is bringing the ObjectAda 10.2 technology to the Linux host operating system. It basically incorporates all of the Ada 2012, same Ada 2012 and Ada 95 and Ada 2005 support that we have currently with ObjectAda for Windows, supporting Red Hat Enterprise Linux version 7.x and version 8.x or the equivalent CentOS distributions. Included will be the Eclipse based IDE using the ObjectAda ADT Eclipse plugins that you saw demonstrated in the demonstrations earlier in today's event. And these again support the latest 64-bit Eclipse version. Projected availability is in Q4 of this year. So it's right around the corner that we expect to have these new products available. But it doesn't stop there. We have in development already work on our next point release of ObjectAda version 10.3. This will be targeting both Windows native and Linux native to provide an enhanced and more comprehensive implementation of the Annex G numerics packages that are part of Ada 2005 and Ada 2012. We have some specific Ada 2012 refinements to add to the release, corrections against version 10.2 that we need to include, some usability enhancements, and projected availability of this is middle of 2021. For ApexAda products that are currently in development, we have a refresh of the ApexAda version 5.2 Linux Cross VxWorks 7 for Intel product. This is an upgrade to support the latest service releases for VxWorks 7 from Wind River to provide compatibility with those new service releases. And then in parallel with that, we have a new product under development, which is Apex Embedded version 5.2 Linux Cross VxWorks 7 for ARM v8. This will, of course, leverage the new ARM code generation for ApexAda and have the same host OS requirements, Intel, Linux, RHEL, or CentOS version 7.7 or later. Projected availability of these new the refreshed release of Intel target and the ARM v8 target is middle of next year, 2021. We have another segment of today's event, which is to highlight some characteristics of the resources that we have within technical support. Presenting this segment of today's event is Ed Kramer, who's a principal technical support engineer.
Thank you, Sean. I know we're short on time, so I'll briefly discuss First, the eSupport portal for those parts that apply to the Ada customers. The eSupport portal provides access to resources such as product documentation, knowledge-based articles, and various product notices. For those who haven't been on the portal, you'll need a customer number and either a service contract number or a sales order number to create an account. And if you have any trouble with that, you can always email our developer tools support email address, which is monitored by our team. And then to discuss the features applicable to developer tools Ada products, the knowledge-based search, which searches technical support articles and documentation. The image on the right shows you the knowledge-based search panel that you can use to find articles that may exist on a question or issue that you're having. Most articles are derived from actual customer support cases. Typically, an article starts with a question or problem and provides steps to resolve the problem, and perhaps a notice of a bug report, and when applicable, steps to work around that problem. The one thing that there's some other things here I'll try to quickly go through before that. There are some popular tasks. You can browse documentation by product, documentation category, and release number. You can subscribe to bulletins and articles, and tools are provided to create and track cases. One exception of using the eSupport portal is our downloads for software, and you'll want to use the our PTC developer tools download server for that. You can get installation media, product documentation, product updates, and where available, e-learning materials. For the product updates, we do require a current maintenance or subscription contact. And that will conclude my portion of the presentation.
Thank you very much, Ed. Our final segment today is talking about the marketing work that is done for our Ada products and some previews regarding events, upcoming events. This is presented by Melissa Wagner, who's our Focus Solutions Group Marketing Manager. Melissa, we're not hearing your audio.
Thanks for that. Yeah, as you know, we usually go to the Ada Europe every year. Unfortunately, this year it was canceled due to COVID, but it looks like it will be taking place next June 2021. So hopefully everything will go on track, and we'll see you there in Spain up next year. And then for websites, I'm constantly making changes to our web pages. You know, when there's new product releases like we just chatted about today, new data sheets, we have thought leadership articles, case studies. So please visit our website on a regular basis for the latest and greatest information. In fact, I'm also going to be posting this recorded webinar on our webpage. And with that, I want to go ahead and open up to questions. I know we're pretty much at the top of the hour. Did you want to get to at least one question? And then if you have questions, be sure that we will be contacting you offline, because we did kind of run out of time today. We'll get those questions answered for you.
Yeah, I think, Melissa, we have a couple of questions that have come in during the event here that I think we can cover. And I'll start with the first one. I think one question was submitted in advance of the event regarding what PTC does with respect to supporting open source developers with free access to our Ada compiler products. And PTC has supported open source developers. This is done through essentially a special arrangement involving submitting a request via the website expressing your interest in our program to support open source development for Ada. We will evaluate your request, perhaps meet with you to understand the particular characteristics of the open source projects that you have in mind. And again, this is something that PTC has supported in the past and will entertain doing in the future for the sake of supporting the usage of the Ada programming language and to have the open source components that are available, to have them work seamlessly with the PTC Ada products. Another question that has come in during the event is with respect to the ASYS support. It says, was the ASYS support upgraded to the full Ada 2012 language? And if so, is there any coordination intended with ISO's Working Group 9, the working group on the Ada standard? With respect to the ASYS implementations, the story is different for both ApexAda and ObjectAda simply because the technology came from different sources. But in general, the answer to the question is the same in that the ASYS implementations are based on the ASYS 2.0 standard, which is now a couple of versions distant from the Ada 2012 language standard. So in terms of ObjectAda, the focus of our development work has been to support, have the compiler support the new Ada 2012 features, and the ASYS implementation is not been upgraded to allow for in looking at all the semantic information that the compiler generates for the newer Ada 2012 constructs. So this is an area that would be nice to upgrade, but it due to other priorities, it hasn't yet been upgraded. And it's true that if it were upgraded, that would facilitate the usage of certain third-party tools with ObjectAda developed by third parties that rely on an ASYS implementation. ASYS is the foundation of other third-party tools. There's one that works with ApexAda called Ada Analyzer, very popular with many of our ApexAda customers. So it's something that we would like to get to. It's just not in the current 10.2 release. With respect to working with the ISO Working Group 9 on the ongoing Ada standard evolution, it comes down to our needing to focus on our resources on the evolution of our products and supporting our customers. And we haven't been a participant in the Working Group 9. Looking at the ongoing evolution of the Ada standard, there's a new edition, a new draft for a new edition under development, and that will be a subject for future consideration within our Ada team here at PTC.
Thanks everyone for your time and appreciate you attending today. Have a great one. Bye-bye.